This is a good question. Solving this question entails following some steps very carefully. If you miss out on even one step, you could end up with an incorrect answer. Take a look at the question. The sum of two numbers is 1215 and their HCF is 81. Then the possible pairs of such numbers are how many is what the question is. Sum of two numbers is 1215. Two numbers we are talking about. Let's say the numbers are x and y. Sum of the numbers x plus y, that is equal to 1215. Their HCF is an 81. HCF of these two numbers x and y is 81. So the highest common factor is 81 for both these numbers, which means 81 is a factor of x, 81 is a factor of y. So x can be written as 81 times something, we'll call it as a. Y can be written as 81 times something else, we'll call it a b. So 81a plus 81b is equal to 1215. 81 is common to both these terms on the left hand side. So 81 times a plus b is equal to 1215. Can take some things for granted. They'll give this 1215 in such a way that it's divisible by 81. Yes, it is divisible. So that makes a plus b, dividing both sides by 81, to be equal to a 15. Now, things to watch out for. One, a and b need to be integers. A and b should belong to the set of integers, positive integers. A plus b should add up to a 15. And this is one very important condition. The HCF of a and b should be equal to 1. These two numbers should not have any factor in common. This part, that a and b, right? Only then the final HCF is going to be 81. If, for example, a and b had a HCF of 2, the final HCF will not be 81, it will be 81 times 2. Whereas this question wants us to have these two numbers to have a HCF of 81. So three conditions to be satisfied. A and b should be positive integers, sum of a and b should be equal to a 15, and these two numbers need to have a HCF of 1. Step 1, what I'm going to do is, I'm going to list down all possibilities where a plus b adds up to a 15 for a and b being positive integers. Let's look at the HCF in a subsequent step. So we have a, b, the sum is equal to 15. Right? 1 and 14 will add up to a 15, 2 and 13 will add up to it, 3 and 12, 4 and 11, 5 and 10, 6 and 9, then one more left, 7 and 8, then 8 and 7 happens. So these are all the pairs of numbers where the two parts are positive integers and add up to a 15. Let's come to the next part where we want the HCF of these two parts to be equal to a 1. 1 and 14, the HCF is a 1. So this is a valid case. 2 and 13, both are prime numbers. So which means they're going to be co-prime, which means their HCF is 1. Also passes the muster. 3 and 12, you'll realize the HCF is a 3. And therefore, this is not the case. We want the HCF to be equal to a 1. 4 and 11, no factor in common. So HCF is 1. 5 and 10, 5 is a HCF, not the answer. 6 and 9, 3 is a HCF, so not the answer. 7 and 8, consecutive integers will always have a HCF of 1. So this is also 1. So how many pairs do we have? 1, 2, 3, 4. 4 pairs of numbers satisfy all the conditions. 4 is choice C.